Welcome, you geniuses. We're looking at differentiation again this week. And the first exercise here, 10.8, we're going to use differentiation to find the turning point. Now, a turning point looks either like this, or like this, or sometimes like this. But we won't talk about those ones so much. We're just going to talk about maximum and minimum points. Now, how do you tell where to find them using differentiation? Just a refresher. You know that the gradient at a turning point or a minimum or maximum point is 0. So what we do is first of all we are going to differentiate. So let's do that with this one here for y is equal to 8 minus 2x. If we differentiate that, we should get dy dx is equal to 2 minus 2x. And then we set the gradient function. This is our gradient function. We set that equal to 0 because we want to find where the gradient is 0, and therefore we can find that 2x is equal to 2 and x is equal to 1. Now the coordinates therefore are 1 comma, and we put this back into the original equation to find the y value. So 8 plus 2 times 1, that's 10, take away 1 squared. So I think it should be 1 comma 9 is the turning point. Now, you already know, because we've got a negative x squared graph here, you know that what we've got is a maximum point. But we can use the first derivative test to determine this. So what we do here is we put in a value before x equals 1. So remember that this is 1 comma 9 is our turning point. So we could put in a value of 0 here and find out what our gradient is. So dy dx, our gradient is equal to 2 minus 2 times 0. So the gradient here is 2. So at this point here, we've got grad 2. And then we could go on the other side of 1. On the other side of 1 would be 2. So let's put in and find what the gradient is there. 2 minus 2 times 2 equals negative 2. Oh, and the gradient here is negative 2. And you can see so essentially you've got positive gradient 2, and then you've got 0, right, a flat gradient at 1, and then a negative gradient at 2. So it's clearly going to be a maximum point. It goes up, flat, down. So there we go. Now we can try the same thing with other curves, but I just want to chat to you briefly about x cubed curves. I don't want to do this one for you. You can do it yourselves, but an x cubed graph is going to have generally 2 points. So this is a positive x cubed graph. You're going to have a max point and a min point. And a negative x cubed graph will look like this. So you'll have a min point, then a max point. Okay, that's in general how it looks. So maybe I will do one for you. Okay, let me do just one. So let's do the C one. We'll go dy dx is equal to 6x squared minus 30x. Now to find where the minimum point is, we're going to set our gradient function, our turning points, we're going to set that equal to 0. Now I can divide everything by 6, so that gives me x squared minus 5x is equal to 0. And then I can factorize that, and that will give me x into x minus 5 is equal to 0. So I've got a turning point when x is equal to 0. That there, 0 times anything is 0. Or 5. So I've got 2 turning points. Now, we can check the gradient before x is 0. So I'm going to go grade at minus 1. And we just pop this minus 1 into this here. Okay. So 6 times minus 1, minus 6. And then minus 30 times minus 1 is positive 30. 30 plus 6. So this is going to be positive, right? 6 times minus 1 squared is 6. Minus 30 times minus 1 is 6. So it's positive. It's positive, okay? And then the gradient at 0 equals 0. And now we do the gradient at 1. 6 times 1 squared is 6, minus 30 times 1 is negative 30, so we're going to end up with a negative gradient for that one. So you can see that it's gone positive, 0, negative. So this one, therefore, is a max point. Now let's do the same with 5. Gradient at, well, what's just before 5? 4. So we chuck that in, and we get 6 times 16 minus 30 times, 6 times 16 minus 30 times 4, and that gives me a negative gradient. And then we know at 5 we've got a 0 gradient, and then we chuck in a 6. The gradient at 6, so we go 6 times 6 squared, 6 times 36, minus 30 times 6, and that gives me a positive gradient. So I've gone negative gradient, 0 gradient, positive gradient. So this one, you can see, is a minimum point. And that's how you use the first derivative test to determine whether you have a if you have a minimum or a maximum point. So if I was to sketch this, it would be something, I know that I've got a maximum point, and then I've got a minimum point, and this maximum point is at 0, and I could chuck in that 0 to get my y value. I could chuck it into this equation here, and this minimum point is at 5. Okay, and you can check this on Desmos. Alright, take care guys.